Okay, what you're looking at here are 4 different pictures. 2 of them I consider to be the same style. You have a triangle, you have some form of a rectangle. I know it has square up here. Squares are rectangles, by the way. They're just a special case of a rectangle. And then you have a circle. On Friday, I hinted at the fact that we're going to be going into the formulas for volume and area. That's what I hinted at. Today you actually get those formulas, so we're going to actually look at those. But the people who are going to be successful at doing volume and area and surface area of 3-dimensional shapes need to know these formulas first. These will help you make sense of 3-dimensional pictures. These are 2D pictures only, right? Flat surfaces. But the people who are really good at these will be very good at 3-dimensional shapes. These are something that you should have had in junior high, or maybe earlier, but probably not at this level of difficulty. So today I want to review these, do maybe an example or 2. I'll probably do 2. I'll probably do a triangle and I'll do a circle. I think rectangles are pretty straightforward if you just look at the formula on how to do it. But triangles and circles are usually the ones that people need to see to know how to type with their calculator. Then once we're done with these 2D pictures, then we're going to move into 3-dimensional stuff. And we'll talk about how to find surface area and volume. So I'm going to assign homework today. The homework that you're going to get will be due on Wednesday this week, so it is kind of a short turnaround. But the thing is, all you're doing is you're typing numbers in the calculator and hitting enter. That's really all you're doing, so it shouldn't take you very long. You just have to know what numbers to type and where to type them and how to write it down. So I think it's pretty easy. Like, especially if you have a calculator, it should be really quick calculations. This stuff is not difficult by any means. Okay, let's do a triangle first. I know some of you are still writing. Continue to write. Continue to write down your formulas. So we'll start with the triangle first. We'll do a circle second. As you guys are writing, just a reminder, you're going to retake the test for me. I know some people stopped in last week. I had a homecoming stuff going on all the time, so it was kind of hard. Try to stop in maybe tomorrow morning and start reviewing. I have a bunch of geometry kids coming in tomorrow morning to review. I had maybe 2 kids, I think, last week that actually did take a retake. They're going to look at their scores probably tomorrow on that. But if you're going to retake my test, you have to spend a minimum of 10 minutes with me in the morning, and then you can retake it at a later date. Some people haven't spent time, they just thought they were going to come and retake. You have to spend a minimum of 10 minutes with me to review. So get that done tomorrow, or today after school maybe if you're around. But not Wednesday after school, because I have meetings all Wednesday after school. But again, don't forget, if you want to take a retake, come in the morning, spend a minimum of 10 minutes with me reviewing, or tomorrow, or tonight after school. But not Wednesday after school. Don't wait till then. That's a no-go. I think those scores are online, I think, as of this moment. So you can see what we got. Okay, are we good? Okay, let's do a triangle. Here's your first triangle. We're going to do 2 different types of triangles. I'm going to do this first one for you. Let's put some numbers in here. Let's say this is 5 inches and this is 4 inches. Let's say this is 7 inches. Let's say this is 10 inches and this is, let's go 11. I don't know, I'm just making up numbers like this. Okay, so what you're going to have to do in your homework, this will be like the first problems, let's say. They show you a picture like this. They're going to, I want you to ignore what the book questions ask for. I want you to completely ignore the book directions. Number 1, what I'd like you to do in your homework is tell me the name of the shape. So what is that shape?
Triangle.
Boom, there's point 1. Number 2, you have to find perimeter if possible. So perimeter is the distance around the object. Okay? If it's 2-dimensional, like this. Your first problems, they're all 2-dimensional. So perimeter of this triangle, because you guys said that, so number 1, you already got a point for saying triangle. Number 2, you have to find perimeter. Perimeter is you add up the walls on the outside. So you start here, and you work your way around until you get back to it. You add up the walls. You add up the outsides. So 11 plus 10 plus 4 plus 5, and what do we get?
32.
32. So 32. Okay, questions at all about that? sure that's 32?
It's
30.
I was gonna say, that didn't look like 32 to me. 30 inches? Do you add those up? Okay. All right. Questions on how to find perimeter, how to add up the numbers. Notice I didn't add the 7. Why didn't I add the 7 in there?
It's in the middle.
It's in the middle. I don't need the inside, I need the outside added up. Do we feel comfortable with perimeter? You do that for every shape. You do it for squares, you do it for rectangles, just add up the outside walls. The only difference between squares and rectangles, you can actually transfer the numbers around because rectangles, 2 walls have to match. Same as squares, certain walls have to match. All of the walls match on a square, but it's pretty straightforward. I don't think I need to go through that again. Now, area though, area is different. Area on a triangle, area is how many little square tiles fit on the surface. So to find area, you take the base, you take it times the height, how tall it is, not a diagonal, but how tall, straight up and down it is, and then you cut that number in half. The reason why you cut it in half, it's half of a square, basically, or it's half of a rectangle. Because if I were to complete this triangle, to make it a rectangle, you take the base times height, and then you cut it in half to make the triangle itself. So my base, how big is my base in this picture?
9.
9, that's the total base. So it's 9 inches. You take it times how tall it is. Well, the height is what, 7? That's how tall it is. It's 7 in height, 7 inches. And then you cut that answer in half once you multiply those together. So 9 times 7 is 63 inches squared, because that's 9 times 7. And then we're going to cut this in half. And that should be 31 and a half or something like that. Square inches squared. Why you put inches squared? It's how many square inches, like square tiles, fit on that. That's why it's in square inches. Your book says change all the labels into inches. You can ignore the book directions. If they give you yards, just stay in yards. I don't care. I don't know why the book feels like you have to always go back to inches. I don't understand that. You can go with whatever label they have. You just have to make sure that on your picture all the labels are the same. That's really the only thing you have to make sure of. Okay, is there any questions with how I found area or how you find perimeter? Usually area is the one that most people aren't comfortable with. They just haven't seen that before, or if you have, you just didn't remember to do that. You take the base, whatever the total base is, the bottom that sits on, and the height straight up and down. Notice I didn't use the diagonals. That's not height. Okay, now let's talk about, because I said I want to do a second triangle here. I want to do a triangle that's a little more challenging. So is everyone good with this picture? Everyone's got the numbers written down? Okay, again, you're just using a calculator. You're just typing stuff to enter, write down a couple things that you're doing, so I know how you're coming up with your crazy numbers if you get it wrong. Which I don't know how you would, but. All right, let's do another one. All right. Okay. Let's say this is 8 feet. Let's say this is 9 feet. And let's say this is 15 feet. Actually, not 15. Let's get rid of that. Let's get rid of this one. Let's make this interesting. Let's leave it like that. Okay, that's your second one. Name of the shape? Triangle again. Okay. Perimeter. Can we find perimeter?
No.
Right now? No. Why?
You don't have this.
We don't have the missing wall, right? The diagonal? You can find it. There is a way to find how long the diagonal is on a special type of triangle, and this is a special type. This triangle is a right triangle. There is a formula that we have that can help you find the missing wall on a right triangle. One of the walls. It doesn't matter which one's missing. Okay? We're going to find that first. You have to do this. I think there's one problem in your homework you're going to have to do this. One in all the homework. Okay? It's called the Pythagorean theorem. You ever heard that before? In fact, I'm going to write that down. The Pythagorean theorem. We're going to look at this theorem a lot more in like chapter 4 and chapter 9, and we're going to come back and we're going to prove what it is and why it comes out. But today is your first day to see it. The Pythagorean theorem is used to find missing walls on a triangle. Missing sides. missing sides of right triangles. That's the only type of triangle it works for. It's got to be a right triangle. If it's not a right triangle, you can't do this formula. You have to like break the picture up into right triangles for this to work. And how it works, this is the formula itself. A squared plus B squared equals C squared. It's one of the most famous formulas in math because it's stupidly simple. Now what A, B, and C are? A and B are the walls that make the base and the height. So this, it doesn't matter which one's which. This could be your A, this one could be B. It's whatever the base and height is. I don't care which one's which, A or B. But then the diagonal is always C. That's the wall you're missing. In this case. Now, it doesn't matter which wall is missing as long as one out of the three is missing. So you could be missing the base for all I care. This number could be missing. But then when you plug it in, it would be A squared plus 9 squared equals whatever this number squared is. Because the C is always the diagonal, it's always the big wall. So I'm going to plug these numbers in. So we have, what's that, 8 squared plus 9 squared, and that's going to equal my missing term squared, the C. I'm going to call it C because I don't actually know what it is. Again, I don't care which one's missing. Could be A, could be missing. You'll have an A sitting there. But then you just do the math like normal and solve this. So 8 squared is 64. That's 8 times 8. 9 times 9 is 81. You add these two together, I get 145. Bless you. So 145, if I add those together correctly in my head. And the last step to find the wall that's missing, once I add those together, you're going to take this power 2 to the other side, and you do the opposite of the power 2. You're not dividing by 2, it's a power. You're going to take a square root. This is where square roots come from. This is why we use them. It's for this problem right here. You're going to take a square root to the other side. That's how you get rid of a power. Bless you, everyone sneeze. You're going to take the square root of 145. So on a calculator, how do you type that in? On mine, you have to hit the little second key. Then you find the little square root button. The square root's down here. It's this one. It's not the one with the little X. So it's the little square key. You hit that. You type in 145. You hit enter. It should be just above the number 12. 12.0 something. 12.04. Okay. So my C number turned out to be roughly 12.04. That's what that problem's good for. Now, how did I know what roughly the number was going to be? The square root of 145 is just above the square root of 144. 144 is 12 times 12. That's how I knew kind of what it was going to be. But how I also knew it was going to be before I started is that the diagonal on a triangle should always be less than the other two walls added together. I knew that this wall could not be bigger than 17. It had to be smaller than 17 in length. The reason why it's called a triangle rule, a lot of people don't know this. It's common sense if you just think about it. If you're standing right here, let's say this is you, right here, and you're going to walk home, your home is over here. It's a shorter path walking straight home than it is walking around the block. Walking around the block is more steps. So if it takes you, 12 steps to get home, it might take you 17 to go around the block. That type of thing. So that's how any two walls, it doesn't matter. So if I pick this wall is missing, the other two added together should be more than this wall. That's the idea. That's how it always works. So that's how I can kind of like estimate how big the walls are on triangles. Questions on the Pythagorean theorem. I think you only have to do it once, and hopefully you have that written down. If you haven't written this problem down, you probably should. Because some of you are going to forget how to do it. We're going to come back to this more, but you only have one of these, and I want to intro it today. Because when we get to those later chapters, it'll be nice to know like why we do it and how we do it. What the formula is and why it actually works every time. Okay, do we feel comfortable with triangles? Now that I have these, I can find perimeter now. I can add up the three walls to add perimeter. Now it's 29.04. I add those together correctly in my head. I can find area, base times height, 8 times 9, cut in half, which is 35 feet squared. No, 36 feet squared. 36 feet squared. If I took 8 times 9, cut it in half, base times height. Okay, we're going to triangles though. Does anyone still need the formula? Take silence is a no. Let's go to a circle. Now I'm gonna ask for input.
Fun.
Okay, all right, so here we go. Let's go to a circle and let's do the same thing. Now in circle, they call perimeter, they call it circumference. They don't call it perimeter because we're on a curve. Curves are not polygons, so they have to call it something else. So we're gonna do a circle now. Can somebody give me kind of a decent number, let's put it in feet, for my circle? Make up a number.
12.
12 feet. Okay, say 12 feet. Okay, what you're looking at there, that is the radius of the circle. Radius is from the center to the outside. We'll talk about that more in like the last chapters. But again, in the book, I want you to ignore the directions so that if this is your homework problem, you have to write first it's a circle. So you get a point there. It is a circle. We're moving on. Okay, now we have to find circumference of the circle. So to find circumference of a circle, you take 2 times pi. Pi is 3.14. It's up here, by the way, if you don't know what pi is. Times the radius, times r. So my radius is the 12 feet you just told me. So let's imagine that this is a Ferris wheel. Okay, so we have a carnival game going on. You're on a little tiny Ferris wheel, 12-foot radius. What circumference is the distance you actually traveled around the object. Now that's 12 feet is kind of a small Ferris wheel, by the way. The one in like Clear Lake's like 30 feet in radius. It's kind of big. So what you're finding is how far you actually traveled if you started here and you went around the circle and came all the way back to here again. Like the distance you actually traveled. That's circumference. It's the perimeter of it. So you take 2 times pi. Well, 2 times 12 is 24 feet. Then you're going to take it times pi. If I were to type in pi, most calculators have a pi button. Mine's right here. It's like a couple buttons below. You hit that, you take it times your 24, and that'll give you your number. If you don't have a pi button, just type in 3.14. Just word now. I do.
Okay.
Yep. Bye. Yeah, I'm right now. So, check online. Okay, so for a circle, we're going to take 24 times pi. If I was typing in pi, like I'd go 3.141592. I go about 5 decimal places in. It's not a big deal because it's going to round anyway. So I'm going to take 24 times pi. So 24 times pi, and I get, what, 75.4-ish in that ballpark? That might be a little bit different than yours because I used a lot more decimal places. But that's what my calculator said, because I used like 90 decimal places for pi. My calculator already has a program in it. So, anyone's numbers get close to that?
What'd you do?
I took
Yeah.
24 times pi.
Yep.
Okay. I don't know like how you're typing in pi or what your button does, how many decimal places it goes. Okay, that's perimeter. That's 75 feet around. Why that's important? I'll give you a real life example of this. It was about 3 to 4 years ago. I went to Clear Lake, 4th of July. They had that. They have all the carnival up there during the 4th. I went on the Ferris wheel with it was first my mother, then my nieces, nephews, my sister, and my wife. And I just bought the original Apple Watch, the original one. And the original Apple Watch wasn't really great at tracking distances. It could do workouts and stuff, but it wasn't really good at it. And here's an example of it. So that night, I was coming home from the actual carnival, and it said that I walked 27 miles that day. I was like, I didn't go 27 miles. I maybe walked a block or 2. You know, you park your car, you go to the carnival, you're right. Well, it didn't know what I was doing that day. It thought I was doing workouts the whole time. Because I was getting on Ferris wheels that would go about 5 miles an hour. That's about jogging, running pace. And so it was thinking I was running the whole time in a circle. So it's documenting, like, I just traveled 75 feet. Well, when you're on a Ferris wheel, sometimes they spin like 6, 7, 8, 9 times around before they let you off again. So I did, 75 feet, 8 or 9 times, but I did this with 5 different people throughout the day. And that was just the one carnival ride. I went on the other rides as well. So doing this 5 or 6 times, just this, I traveled over this is almost a half a mile alone on just the Ferris wheel that day. Half a mile, that's a really long way, right? In terms of like carnival ride. And then I was still going on the other ones. So it made sense that I was, I got home and I was like 27 miles. I didn't walk 27 miles today because I didn't know. It wasn't really good at, GPS and accelerometer. Didn't realize I was going, up and down versus right and left type of thing. But it was just kind of funny to me. But this is the practicality. This is the math it does in the background because it's counting how far you're running. So, all right. Questions at all about this? That was circumference. That's distance. Now, area, very simple formula. Area's over there. To find area, how many little square tiles fit on the surface? You take pi times radius squared. Right, it's over there. You can see the formula. It's on the bottom of the circle. So that's where you take pi. You take it times my radius. My radius is 12 feet, and we're going to square that. So to square something, you take it times itself. So 12 times 12 is 144 square feet. Feet squared. We take that times pi, and that's a big number. What is that number?
452.4.
452.4 feet squared, roughly. Square feet. Feet squared is like how many little tiles fit on the surface. That's a big Ferris wheel. I'm going to figure out how many perfect little squares fit on that surface. Yeah, 452 makes sense. I already went 6, and I still have a bunch more to go. Like it fits. 1 foot by 1 foot. I didn't even get close to putting 12 on that. I just put 6 there. They should be way smaller. Okay, questions at all about what area is? It's how many square tiles. That's why the answer is in feet squared. It's square feet. Square little tiles on there. Circumference or perimeter is just the label. It's how far I ran. Okay, we're good with the two-dimensional shapes. Rectangles you should be able to do by yourself. Length times width, that type of thing, or adding up the walls. Same with squares. Length times width, or to find perimeter, you just add up the walls. Okay, three-dimensional shapes. Now I'm going to let you write these down. These are ones I think I had on the board on Friday, which is probably impossible for you guys to see it with the video. But here you go. I'll let you write that down. I'll start and set the camera here. I'm going to do probably 2 examples of these. I'm going to do maybe the cone, and then maybe I'll do like the pyramid. I don't know if I'll do the full pyramid, but I might just talk about it. Because maybe I'll do that one like tomorrow. As you're going to look at the labels here, use the answer key, by the way. The answer key is huge. The people who are going to be really good at this understand the last slide I just showed you. But I'll let you write those down. My goal is to go through the cone today. And if we need to do a pyramid, I can do a pyramid too, but it's not a big deal. Once you get how the labels work, it makes sense like how to do this stuff with a calculator. The labels are a big thing. Like most people look up here and they don't understand what the letters mean. And if you can't read them, scoot closer, that's your own fault. I had poor eyesight and I can still see it. So these formulas that you're looking on here, there's prisms, pyramids, cylinders, cones, and spheres. They're asking to find surface area, so that's the area of each of the surfaces all added together. So it's how many little tiles can fit on the surface, or how much paint you take to put on the whole surface. Volume is the space on the inside. How many little like ice cubes could you fit inside the picture? Cubes, like perfect little ice cubes. Sugar cubes, like could you fit? That's volume. But if you notice the bottom, the answer key, like S stands for surface area, P stands for perimeter, V is volume, B is base area, H is height, L is like the slant or the lines that are used, and then R is radius, again, if you're using circles. But I'm going to do the cone, because I think once you see the cone, you'll understand how they work. So let's write that down and make up some numbers here. And again, I'll post these pictures and stuff on my website. These pictures that you're looking at here are always the pictures that are directly in front of the homework in your book. So if you're like, God, I just didn't understand that picture, or like I didn't quite get the label that he was using, you can flip backwards and forward in your book. It's the page right before the homework every single time. Because our homework's over 2 different pages. Because I mixed and matched ones to find those 2-dimensional shapes. So we haven't seen those. So I kind of picked a little page in the book. Okay, I'll give you maybe another 2 minutes to write those stuff down. Some of you are like scrambling. Some of these formulas are kind of complex. They look complex until you actually figure out how to use them. Again, if you have a calculator, this stuff is pretty straightforward. But it really comes down to, do you understand how 2-dimensional shapes work? So if you don't know the 2D shapes, how are you going to figure out volume first? Okay, I'm gonna do my little cone picture here. So if you want to write down my little cone, I have all the labels that we're gonna need for my little cone. This is a really big cone. It's in yards. So this is like the world's biggest ice cream cone you've ever seen. 10 yards tall, 5 yards across. It's huge. Dirt devil, I guess. Huge. And we're going to find the surface area of it, and then we're going to find the actual volume. How many little sugar cubes can fit in it, or ice cream scoops could be put in there, that kind of thing. Okay, so if you look at the formula over there, the surface area for a cone, so S, is equal to pi times R times L, and then you're going to add pi R squared to it. Now let me explain what this is. We're finding surface area of my little ice cream cone. So you're finding the area of the circle on the top. This is, by the way, this is the circle on the top. And then this is the actual cone itself, and you're adding the 2 surface areas together. Now why you're doing that, the RL times pi is because if I were to like cut my cone and roll it out and take off the top, like there's like a little lid on it, take off the lid and roll it out, this is what a cone would look like if you rolled it out. Radius, the length of how long it is, like the height of it basically, and then this is the curve. And so you take the R times L and you take times pi, and that gives you like the surface area of the cone itself, and then you have to add the lid that you had on the cone itself. That's the circle. That's what you're doing. Okay, so my radius is the 5 yards. We're going to take it times the L. The L in that picture is the slant line. So L is the 13 yards. And we're going to take that times pi. So the slant times the radius times pi. And then we're going to add this to the pi times my radius squared. My radius is 5 yards squared. Square that. And now we're just going to do all the math. So does everyone see how I'm using the formula, like how I'm plugging the numbers in from the picture? Like if you look at your picture there, you can see how the labels are supposed to go and where they go in the formula. Bless you. And again, these, like on test day, these formulas would be on the board. I'd have them right up here. They'd all be written there. All the labels will be there, so you kind of know which part's which. So 13 times 5, that's 65 yards squared. And we're going to take that times pi, that's 5 times 13. Over here, 5 squared is 25 yards squared. We're going to take that times pi. And this is the part where you need a calculator, right? I have to take 65 times pi. And I'm doing each part one at a time. So 65 times pi is 204.2 yards squared. 25 times pi is 78.5 yards squared. So that's the circle, this is the cone itself, and when you add them together, let's add that to 204.2. I'm using way more decimal places than you are, sorry. It's 282.7, roughly, yards squared. If your numbers are slightly off than mine, sorry, I used way more decimals because my pi has way too many. Okay, questions on how I did surface area. And notice that it has yards squared. It's how many little square yards fit on the surface. So that's why it's yards squared, how many squares fit on the surface. Questions at all about that? Define volume of it. Volume formula is over there. What is that volume formula? Can somebody read that off? It's 1/3.
Pi times pi times
Radius squared.
Radius squared times height. Okay, so here's your formula. So 1/3 times pi, and by the way, multiply by 1/3 is the same as dividing by 3, basically. Times r squared. My r is 5 yards squared. That's my radius squared. And the height is the number, the dashed line on the inside. So that's my 10 yards. So 5 squared is 25 yards squared. We're going to take that times 10. So that's 250 yards cubed. Cubic yards, that's how many ice cubes can fit in there. We're going to take that times pi, and then basically divide by 3. So that's the same as multiplying by 1/3, it's divided by 3. So 250 times pi, it's a crazy number on my screen. And then we're going to have to take it and divide by 3 here in a second. But 250 times pi is 785.4 if I rounded. Again, I'm using a ton of decimal places there, sorry. So 250 times pi, and then I'm going to divide that number by 3. So it looks like my overall answer here is it's going to take 261.8 cubic yards of sugar cubes, basically, fitting in that thing. That's quite a bit of sugar cubes, 260. But again, that's 1 by 1 yards. So 1 by 1 yards fit in there, and I'm adding up all those little sugar cubes. So I can fit a lot of them in there. That's fine. These are broken. All right. Questions at all about formulas? Okay. Now, if you're doing like the pyramid, you have to find the perimeter of the bottom times the slant line. Have that happen. Add the area of the base. The base is rectangles. So you have to know your areas of objects. But let me get rid of this. Hopefully everyone's got their formulas down. Here's your homework. It's due on Wednesday. Let me get rid of this. Okay, here it is. It's over 2 different pages. Remember, I want you to ignore the book directions. All the book directions. You have to name the picture. That's it, name the picture. If you can, find the perimeter area of these. And if you can, like maybe on the 3D pictures, you gotta name it, and then figure out surface area and volume for it. So ignore the book. The book's gonna have you do a bunch of crazy stuff, just ignore it. Do what I'm asking you to do. So page 61, sorry. Numbers 6 through 8, 17 through 22, so that's the stuff with 3D pictures and stuff, so, or 2D pictures, so you're gonna have to name it, perimeter and area. And then the second page is page 70, and this is 3D pictures, so you still have to name it and then try to figure out surface area and volume. If you can. Because some of the pictures don't have any numbers, so all you have to do is just name the object. Oh, it's a rectangular pyramid. Moving on. So ignore the book directions. They have you doing stupid, crazy stuff you don't need to do. If you have a calculator, this stuff should be easy as long as you have your formulas written down and you know how they work. I will go through an example or two tomorrow right when you walk in, so I might give you a couple of freebies if you're in the room and you're paying attention. I might pick out a couple of those out of the homework. Okay, when does it due? Due Wednesday. Wednesday. If you're going to take retakes, because I know some people came in last week, they were trying to take retakes, but it was homecoming, it was crazy. Come in today after school, tomorrow morning, start reviewing. You have to spend minimum 10 minutes with me before you can retake that test. Get that stuff done. Don't wait until tomorrow night to start this homework. The reason why, There's football, cross country, there's volleyball, there's tons of stuff going on these next couple nights. Volleyball and cross country I think is really far away tomorrow. Volleyball's like a 2-hour drive, it's like Armstrong. You guys are only going to see, that's not bad. Volleyball's going like Armstrong or North Union, that's a ways. So don't wait until tomorrow night to work on it, you'll be tired. So work on it today, work on it now.